Okay, so we're going to look at inverse trigonometric functions. And remember that inverses are going to be functions that undo each other. We've already talked about this a little bit with sine and cosine and things like that, where we can do this sine -1 here, which represents inverse. We looked at that when we had to solve for an angle. You had to do that on your last test. So now this is a scan of my notes. You're going to be able to read your notes a whole lot better in front of you. So definitely follow along because I know this didn't copy great necessarily, but hopefully you can figure that out. And I'm a little bit congested. I apologize, so I sound kind of sniffly. Anyhow, so the inverse of each of the three trig functions, the most important thing you're going to have to pay attention to is the domain. This is what gets people every single time, okay? So when we want to do the inverse of a sine, this would be if I want to work backwards. So let me go to the unit circle here. I know by looking at this ordered pair that the sine of pi 6 is 1/2. So I could ask instead what the sine inverse of 1/2 is. So the question is, what angle has a y value of 1/2? And so the answer would be pi 6. That's what we're going to be looking at today. So if I ask you for the sine, the cosine, whatever of an angle, your answer is going to come from some relationship of x's and y's from the ordered pair. If I want to ask you to find an angle instead, the angle is the thing you need to know, then I'm going to ask you a sine inverse. And if it's an inverse, that means you're going to start with an ordered pair and work your way backwards to figure out what the angle is. Okay, we'll come back to the unit circle in just a second here. Okay, the inverse sine -1 like this is a graph of the restricted sine function from -pi halves to +pi halves. Let's think about why we have to restrict it. So we know several things about functions, okay? And we know about their inverses. Remember that if I want to graph a function's inverse, I just switch the x's and y's. So for example, this is the sine curve from -pi halves to +pi halves. The ordered pair pi halves 1 becomes 1 pi halves on the inverse function. You switch the x's and y's for everything. So that means that if I'm restricting the domain from -pi halves to +pi halves, on my inverse, I'm restricting the range from -pi halves to +pi halves. Now we're looking at the y's up and down. Why do we have to do that? Well, think about what the sine function would actually look like. I don't have my iPad, so I can't draw on this here, but if you kind of follow my mouse, we'd start at 0, we would go up, and then we'd come back down, and then we'd come back up. Well, if I were to turn that sideways and this were to keep going and come back this way and come back this way and come back this way, we would no longer pass the vertical line test. That would mean that our inverse is not a function. And remember, if the graph is a function and its inverse is a function, then we know there's a one-to-one relationship. That's what we need to happen. We need a one-to-one. I need to know for sure that if I take the sine of theta, I'm going to get a certain answer. And I need to know that if I do the inverse of that answer, it is only going to take me back to one possible angle. So the way that long ago we decided to restrict the sine function was just on one little section of the curve that goes from the minimum up to the maximum. So we chose to restrict it from -pi halves to +pi halves. When we reflect this over y equals x and get the inverse like this right here, you see now this, we have no issues. It all passes the vertical line test and we're good to go, okay? So when we find inverse values, so if I want to find the exact value of sine inverse of x, okay, then I need to know, what this is saying is, find me some angle theta so that the sine inverse of x equals the angle theta. Well, if I know that theta is equal to sine inverse of x, that means that x is equal to the sine of theta. So that's the question that we're really asking. If I want to know the sine inverse of x, I'm saying what angle has a sine of whatever x I'm trying to get, okay? Now this is important. We have to restrict from -pi halves to +pi halves because that's what we chose on our graph, but also for some other reasons. If you look at your unit circle here, okay, and we look at y values, if I go from, let's say, 0 to pi, this ordered pair pi 6 has the exact same y value as the ordered pair 5 pi 6. That's confusing. That would not be 1 to 1. That means that I could get two different angles that both have the same sign. So for sine, we have to choose from two quadrants where the signs switch so that my answers are different. At pi 6, I have positive 1/2. And at negative pi 6, or 11 pi 6, I have negative 1 pi halves, okay? So that is why with sine, we're going from negative pi halves up to positive pi halves. You only get to choose from quadrants 1 and 2 when you're doing the inverses. You're never even going to look at 3 or 4. Those will never be the answers. Now, you'll notice the way that I was saying things. We said we're restricting the domain from negative pi halves to positive pi halves. 11 pi 6 is not between negative pi halves and positive pi halves because remember, 11 pi 6 would have to go all the way around like this. That's too big. I need to go straight from 0 down to this. So you have to name them using negative angles. It's going to be the mirror image of quadrant 1. So pi 6, pi 4, pi thirds, pi halves. But you're going to go in the opposite direction. Negative pi 6, negative pi fourths, negative pi thirds, negative pi halves. It would be wrong to call it 11 pi 6 when we're talking about inverses, okay? You have to go negative to positive. Okay, so if we look at some examples here, let me see if I can make my unit circle a little smaller so that we can see this problem. There we go. Okay, we want to find the exact value of sine inverse of square root of 2 over 2. So the question is asking, and remember, sine, we really only want the first two quadrants, so we can ignore the other half of the graph completely. We can only choose from quadrant 1 and quadrant 2. I want to know where sine, remember sine is the y-coordinate, so where does sine equal the square root of 2 over 2? So I look at all my y's, and we see it's going to be this one. So pi fourths is the answer there. This is basically asking what angle has a sine of the square root of 2 over 2. Okay, so we can work backwards there for that. Let's look at another example. We want to find the exact value of the inverse, sine inverse of negative square root of 3 over 2. Well, the y value is negative square root of 3 over 2 right here. Remember, we only get to choose from quadrants 1 and quadrants 2. It's the same over here, but we don't want to look at that. We only get to go from negative pi halves to positive pi halves, okay? Now, notice my answer here. I look at this and I go, ooh, 5 pi thirds. We can't call it 5 pi thirds. We have to rotate down to get to this, so we would need to call this negative 1 pi third. If you put 5 pi thirds, that is wrong. It has to be from negative pi halves to positive pi halves. Okay? All right, let's come back to this. So that is for sine. Sine is quadrants 1 and quadrants 2. You have to choose between negative pi halves and positive pi halves. Cosine, same idea, but where we chose to restrict cosine is from 0 to pi. We don't want to go from negative pi halves to positive pi halves because that would fail the horizontal line test right there. From 0 to pi right here, we pass the horizontal line test the whole way down. So that's why we do it there. Now again, if you look at your unit circle, let me pull out the whole one here. Okay, looking at cosine now as our x values. If I were to look in quadrants 1 and 2 like we were doing last time, the x values match here. So I can get more than one answer. That's not 1 to 1. They're both positive here. So in order to get two different x values, I have to go the positive side of the x and the negative side of the x. So we're going to choose from 0 to pi this time, okay? Let me narrow this down for us. Okay, so we're only looking at 0 to pi for cosine. This is just stuff you got to memorize. Sine is from negative pi halves to positive pi halves. Cosine is from 0 to pi. For the same exact reasons kind of that we talked about. The process, though, is exactly the same. So if you turn the page, we want to find the exact value of the cosine inverse of negative square root of 3 over 2. So cosine is the x. So I'm looking at the first component of each of these ordered pairs. Here's positive square root of 3 over 2. That's no good. Here's negative square root of 3 over 2, and that is 5 pi 6. I can call it exactly that because that's between 0 and pi. So that's why the answer for number 3 is 5 pi 6. Okay? Now, tangent. Tangent is just like sine. It goes from negative pi halves to positive pi halves. But the problem with tangent is, remember, it's undefined at negative pi halves and positive pi halves. That's why we have these asymptotes. So we just can't choose pi halves or negative pi halves. We can choose anything in between. So when we look at tangent, we're going back to just looking at half of the circle. Okay? So we are only looking at, I want this to look the way I want it to. We're only looking at quadrants 1 and quadrants 2. So over here. Oh, I've got this moved over. That's why it's not cooperating. There we go. Okay, quadrants 1 and quadrants 2. Now, here's what I want you to add on to your unit circle. And I think they're here in the table. Yes, they are. Okay. At 0, 1, the tangent is undefined. So you can label that one as undefined. At, well, maybe we should start at the bottom. Looking at this table. At negative, this one is undefined, negative pi halves. At negative pi thirds, which is 5 pi thirds, you can just kind of put it out to the side. The tangent is equal to negative square root of 3. At negative pi fourths, the tangent is equal to negative 1. And at negative pi 6, the tangent is equal to negative square root of 3 over 3. Add these to your unit circle. At 0, it's 0. And then it does the exact same thing, but in reverse on the other side. So pi 6 is going to be square root of 3 over 3. Pi fourths is positive 1. And pi thirds is negative 3. And then again, pi halves is undefined. You need to add all of those things onto your unit circle. Your unit circle quiz number 4 is going to ask for the tangents in quadrant 1. If you know the tangents in quadrant 1, you just switch all the signs and go in reverse. And that gives you the tangents in quadrant 4, okay? So, my dogs are barking. I don't know if you can hear that in the background. I'm about to go yell at them. So, working the same way, if we want to find the exact value of the tangent inverse of the square root of 3, well, I don't have that labeled on my unit circle, but you hopefully do because you just did it. I can look at this table right here. Tangent inverse of positive square root of 3. I see that that is this one. So the answer is pi thirds. The second one wants to know, where does the tangent equal negative 1? That happens, negative 1 here, at negative pi fourths. Okay? So that is the only thing that you need to do today. You're just practicing reading your unit circle backwards. Okay? We'll look at compositions tomorrow, and we'll start with questions when I come back. So I hope you guys have a good day.